waves get lost in the ocean. 7 billion swimmers, man, I'm going through.
So our next session today is really going to focus on our clinical trials and cohort studies. Participating in clinical trials and research studies is critically important, as this is the only way we find out which new treatments work and how we progress ideas from early discovery into clinical practice. So the next set of presentations are focused on some of the clinical trials and research studies currently occurring in the MS flagship. So each presenter will present, and we'll use the same format that if we have time after our presentations, we'll open up the floor for questions. And our first presentation today is from Tash Stevens, and she's going to be talk to us about the TORUS 2 trial results and where to now. Thanks, Tash.
Okay, thanks, Tracy. So if you've been to Research with Connections before, you would have heard us present about TORUS, or our magnetic brain stimulation trials. Previously, we've presented the results of the TORUS 1 trial, which was our safety trial. Today, I'm going to tell you about the results of the phase 2 safety and efficacy trial. So what is TORUS? Another acronym, which Bruce proved earlier. We love acronyms in clinical trials. It's probably the first thing we do so that we don't have to tell you the very long title, which in this case is a randomised controlled trial assessing the safety and efficacy of repetitive transcranial magnetic stimulation, or RTMS, for people living with MS. And just to show you how we derived the TORUS acronym, it is real. It does come from the title. And that just helps us to easily convey the study we're talking about. And thankfully for me, Sam gave a beautiful introduction to demyelination this morning. So a very quick recap on this process. So as we know, in MS, the body's own immune cells attack the central nervous system, causing cell death, lesions, and loss of myelin. And it's the myelin insulation wrapped around the nerve cells, which without this insulation, the nerve cell communication and processing of information is slowed down, and this leads to increasing levels of disability. And so it's this demyelination process that we're trying to reverse in the TORUS trial. We've already heard this morning that the current drug treatments for MS, DMTs, reduce the number and severity of immune cell attacks, but there are no treatments that repair, restore, or prevent further damage to the nerve cells. And this has been the MS community's #1 research priority for a while, and so TORUS 2 is trying to address this. So enter RTMS. What is repetitive transcranial magnetic stimulation? So hard to say. So RTMS is how I'll refer to it moving forwards. So you can see the pictures on the right-hand side there. That's what an RTMS machine looks like. It's essentially a magnetic coil that delivers an electrical current to the brain to improve brain cell activity. It's currently used to treat depression and other psychiatric disorders. And there has been research in mice that has shown that a low-intensity stimulation can significantly enhance remyelination. And this work was done in Kayleen Young's laboratory here at Menzies. So we took this discovery from Kayleen's laboratory through to the phase 1 clinical trials in 20 people with MS here in Hobart, and we concluded that RTMS in this low-intensity pattern is safe, tolerable, feasible, and acceptable. And that was concluded, I think, back in 2021. So we then moved to the next phase of clinical trials, which is a larger trial, or the phase 2 trial. And what we needed to show was whether this actually works. And so our hypothesis was that 20 sessions of low-intensity RTMS delivered in this very particular stimulation pattern, known as an intermittent theta burst stimulation pattern, delivered over a 4 to 5 week period, would result in the measurable addition of myelin in the brains of people with MS. And that this addition of myelin, or this brain repair, would lead to significant improvements in cognitive, functional, and other patient-reported outcome measures. Now, the intermittent theta burst stimulation pattern, which is pictured at the bottom, was a quite important thing to note. So this is a 10 bursts of stimulation over a 10-second period, followed by an 8-second gap, and then repeated for 20 cycles, totaling 600 pulses over 3 minutes. And this is repeated on the left and right side of the brain. And it's important to use this very particular stimulation pattern that was shown to be effective at adding myelin in the brains of mice. A continuous stimulation pattern does not result in the addition of myelin. So Taurus 2 recruited 104 people from 6 sites around Australia. So we partnered with people in Perth, Melbourne, Hobart, Launceston, Newcastle and Brisbane. People needed to be diagnosed with MS and relapse-free for 6 months to join the trial, and aged 18 to 65 years, and they needed to have an EDSS between 1.5 and 6, meaning that they were able to walk with limited assistance. We then excluded anyone that had predefined criteria where RTMS or MRI would not be safe to perform in those individuals. People were then randomised to 2 different groups, either the RTMS active group or the sham placebo group. They had a 2-to-1 or double the chance of being randomised to the RTMS group. And then both groups received the 20 intervention sessions every weekday from Monday to Friday over a 4 to 5 week period. So they had the 600 pulses for 3 minutes on each side of the brain, left and right. And the RTMS group had the RTMS machine set to 25% stimulation, and the sham group, our placebo group, had 0% stimulation. We then compared both groups, both before treatment and at 4 weeks and 4 months after treatment, on a variety of different measures. So the primary measure was the Multiple Sclerosis Functional Composite Score, or MSFC, another acronym, and that includes the 9-hole peg test, 25-foot walk test, symbol-digit modality test, which in combination measure upper and lower limb function and cognitive function. We then explored various other surveys of anxiety and depression scores, quality of life and fatigue and sleep. We also assessed adverse and serious adverse effects of treatment, and we did the brain scans to look at the addition of myelin before and after treatment. Now the results. So unfortunately, we did not find any significant improvement in any of these outcomes, and this was very disappointing and also a little surprising. And I'm going to circle back to why perhaps this was. When we looked at safety, we found an 11% increase in side effects caused by RTMS. The majority of these were known mild side effects of treatment, which included things like dizziness and tingling sensations, which resolved quite quickly afterwards. There were no serious side effects caused by RTMS, and so we concluded that RTMS continues to be safe for people with MS. Our blinding was successful, and that means that participants didn't know and couldn't guess which treatment group they were in. So this is important for the validity of our results. Now, when we looked at compliance, this was quite interesting. So we have 3 different coloured bars, and the compliance is looking at whether people were able to complete the treatment course of 20 sessions over 5 weeks with no more than 3 days between each session. And so we can see in the green that in both groups we had 100% compliance with the 20 intervention sessions. So everyone completed their full treatment course. However, in the purple bars, we can see the completion within 5 weeks was a little lower, sort of around the 92 to 97% mark across both groups. However, complying with less than or equal to 3 days between sessions dropped to around 39% and 56% across the RTMS and sham groups. Now, this is important because in mice, the effective treatment protocol was given every single day for 28 days with no break in between. However, in humans, we allowed up to 3 days between sessions to allow for weekends, sickness, long weekends, and just the general feasibility for people coming in every day to receive treatment. And so it's very possible that this has actually had a negative effect on the treatment outcome. And the main reason given for more than 3 days between sessions was illness, particularly COVID-19. I think that also demonstrates how difficult it can be to move a trial from a single site trial. So in the Taurus 1 trial here at Hobart, we had a 85 to 90% compliance rate across all 3 of those measures. But when we moved that to 6 sites around Australia with 104 people, that compliance came right down. Okay, so in conclusion, unfortunately, 20 sessions of low-intensity RTMS delivered in that intermittent theta burst stimulation pattern over 4 to 5 weeks in this case, did not result in the measurable addition of myelin to the brains of people with MS, and it did not significantly improve cognitive, functional, or other MS outcomes. So, what does this mean for us next? Well, we haven't given up hope. We understand that upscaling the treatment from mice to humans is quite complex, and there's a lot of mathematical modelling that happens to do this. And if you remember learning about Pythagoras at school and ever wondered, would I ever use this in real life? This is where it's used. And so we may have gotten some of our parameters wrong and not taken every variable into account. It's a little bit like fine-tuning a radio. You need to get the frequency exactly right to hear the music, and I think that's what we're looking at here. Compliance obviously had an impact as well, and so we're actively seeking funding now for the next phase of TORUS to see if we can adjust some of the variables to achieve a better outcome. And so that might look like what's called an umbrella trial, where we have lots of different treatment arms looking at different variations of the treatment protocol in a small group to then figure out the most effective treatment protocol to progress to a larger trial. And so we would be looking at doing a longer treatment duration, so more than 6 minutes, more than 20 sessions, more than 4 weeks, and maybe a higher intensity of stimulation. Still in the low intensity range, still in the intermittent theta burst stimulation pattern, but maybe up to around 50% output. The effective treatment in depression, for example, is up around that 80% range. So we still want to come down in the low intensity range, but maybe more than 25% is needed. We might need to insist on daily sessions with no breaks for weekends, and we may also refine the MS population. So there may be subgroups of the population that actually respond better to this treatment. So maybe a lower EDSS range, younger age, or type of MS might be important here. Okay, so I'd really like to acknowledge the consumer involvement that we've had throughout the TORUS trials, both TORUS 1 and TORUS 2. And I'm going to take a little bit of time here to properly acknowledge the actual impact that the CCI has had on the project. So right back at the beginning, Bruce presented the trial to the Consumer Advisory Committee, and we also provided them with the participant information sheets and consent forms. And we gave them an anonymous survey to ask them, so what do you really think of this? And they were not backwards in coming forwards, and they told us that it's too long, it's too technical, it's hard to understand, the purpose and risks are unclear, the daily treatment's not feasible, and your level of reimbursement is not enough. So we took all of that on board and we went away and I redesigned the patient information sheet and consent form, and you can see the before and after on the screen. And we actually reduced the reading score from 16, or a doctor level, down to 9, suitable for a general audience, and from 9 pages down to 7 pages. We added the feasibility and compliance tests, which ended up being extremely important, as you've just seen, and we increased the reimbursement levels from $20 to $50. We then invited Meg to partner with us on the trial, and Meg has championed the trial through media campaigns and information videos, helping us with recruitment and promotion of the study. She's also helped us to review our results letters that were sent to participants to make sure that we were sharing the results in an easy to understand and sensitive way, and co-authored our protocol and results papers for TORUS 1 and 2. And as you heard from Meg before lunch, she came with me to the ACTA conference in Melbourne in November, and hopefully the next step for us will be to actually review properly the impact of CCI on the trial and produce a newsletter article for the flagship newsletter. So thank you, Meg. Thank you to the Consumer Advisory Committee and all the study participants. There's probably a few of you in the room. And to everybody behind the trial. It's a huge team, both here at Menzies and as well around Australia, that have contributed, and to all of our funders as well. Thank you.
Thank you, Tash, and you probably could sense the disappointment in from Tash when those results were were uncovered, but also hopefully you could hear every experiment, every trial has a real purpose, and we learn from them no matter what the results are and design better trials next time. And that is how breakthroughs are made. So congratulations to the team for their resilience and continuing to do that work.